Happy Friday, guys. Today I'm just going to show you how to do the first two sections of the Delta Math assignment. The first thing I'm going to talk about is what's called rotational symmetry. So a lot of things have rotational symmetry. What that means is you can change the angle of a shape and it should still look the same. Like, for example, this hexagon, if I change this to 60 degrees, it looks the same as when the angle is 0 because it has 60-degree rotational symmetry. So if I go 120, we'll see the same thing again, 180. So every 60 degrees this is happening. The reason why the number is 60 is because if you take 360 divided by 6, you get 60 degrees. It's not a coincidence the hexagon has 6 sides. So that's basically how you can figure out how to do this. I'm going to show you some examples on the Delta Math itself with those problems. But hopefully after that, you should be able to do it on Delta Math. Okay, it says complete the following sentence. This either is has or does not have. So for all of these problems, you're going to have to choose one of those two options. If it does not have rotational symmetry, it means that the smallest angle to see the shape regain its original form is 360. Okay, so for example, if you take a person, a stick figure has 360-degree rotation. It does not have rotational symmetry because you would have to rotate it a whole 360 degrees for it to become itself again. Another example would be like a square. The smallest angle, I'll just say SA, the smallest angle would be 90 because every 90 degrees you turn a square, it will look the same as when you started. Let's see. For this, I'll call these spokes. You just basically count these spokes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Since it has 12 spokes, I take, first of all, it does have rotational symmetry. And you'll notice that some of these spokes are faced a different way. So some of these can be kind of tricky. Okay, in this case, all those spokes facing that way tell me that if I were to rotate this spoke to that spoke, this is my angle of rotation, whatever that angle is. So instead of taking 360 divided by 12, I'm going to take 360 divided by 6 because what we really have is 6 spokes that are going to show me the same thing. Because if I just rotate it, for example, if I rotate number 2 over to number 1, that picture will not look the same as when I started. So once again, we're going to take it divided by 6. This would be 60 degrees. I'll show you some more examples. Hopefully it'll start to make sense. Let's see. This has rotational symmetry. So we have to figure out the smallest angle. And remember, this is for when it looks the same. If that number is 360, then it does not have rotational symmetry. But in this case, I think if we just turn it 180, like if we take this point and rotate it so it goes down here, I believe 180 degrees, or 360 divided by 2, is going to be my smallest angle here because the shape will look the same after that rotation. This shape, I'm noticing these points right here. Those are what I'm going to consider to be my spokes. I have 1, 2, 3 of them. If I take 0.2 and rotate it to 0.1, it's going to look the same. So it has rotational symmetry. And that angle is going to be 360 over 3, which is 120 degrees. Okay, we talked about the square before. This does have rotational symmetry. And you can really see that if you just look at the vertices. The reason why it's 90 degrees is because we have 4 vertices here. 360 over 4 is 90 degrees. Okay, and finally, an example where it does not have rotational symmetry. If it does not have rotational symmetry, you don't have to put an angle in. Basically, it's just telling yourself that, okay, if I take this point, I would have to go a whole 360 which is not rotational symmetry, in order to get back to the shape I had. I'm going to go to delta math now to show you how to do the lines of symmetry. Okay, for the next section of the delta math, we're going to talk about lines of symmetry. Lines of symmetry are basically you take any shape, and if you can draw a line across it such that when you reflect over that line, the shape looks the same, that's a line of symmetry. So for example, these blue lines here over this X, these are both lines of symmetry. You can see that if we reflect over this horizontal one, we would see that the shape looked the same. Or if we reflect over this vertical one, we would see that the shape looks the same. So it is just preserving the shape even though we're doing a reflection. Let's see. I'll do a couple examples here. It says draw all lines of symmetry. Sometimes there are none. So you just basically submit your answer without drawing one. But here I can see that if I draw a line through these 2 points, if I reflect over that line, the arrow should look the same. So I'm going to go ahead and submit this. I think I have one line of symmetry. We can tell that something like this wouldn't work if we reflect over that line. This would not look the same as the original. So I'm going to delete that. We'll just submit the one line of symmetry. Boom. Okay, and if you're a little bit off, you can see I'm not like exactly perfect, but if you're a little bit off, it should be fine. Just try to get as close as you can, and delta math should recognize it. Going on to the next one, right away I see the same thing, a vertical line of symmetry. I'm going to try to make that cleaner. And I also see I could draw this line from vertex to vertex here. Oops. This is easier when you have a mouse, I promise. Okay, we could also draw that line. If I reflect over any of these lines, it will work. Now, there's actually more than just these two. If I reflect over this line, okay, I should see, well, first of all the lines are crossing. Okay, I should see that that would also work, and so would this line right here. And even though I did this kind of messy, I just want to test out how nice delta math is. Hopefully it lets me use this, but all of those lines should be good. And you can see my lines were a little bit off, but delta math still gave me full credit. We have 4 lines of symmetry. And you can always click on show example for all of these. I highly recommend that, show example, and you can look through more of those. Lines of symmetry. Well, if we drew a vertical line, that would definitely be a line of symmetry. If we can get it vertical enough, there we go. Okay, and this looks equilateral, so it looks like we could do this on all 3 sides. Okay, this would have 3 lines of symmetry. If I reflect over any of those lines, the shape would look the same. Boom. And we'll try one more just to see if it gets any harder. This is the exact same problem, except instead of a triangle, it's a kind of 3-spoked little snowflake. So that is the same. Okay, and then we'll try one more. Oh, this is the same thing again. So once again, you just have to look for these lines. If you draw too many, that's kind of a good problem to have. You would rather have too many than not enough. So hopefully you see all the symmetries going on. And remember, you can always show an example. If I click on show an example, they will show me tons of examples, just like the ones we already did. Okay, and just like ones that you'll have to do. If you have any issues with this, once again, please look at those examples, and I'm hoping this video helps. I recorded it at 7:30 a.m. this morning, so you better be watching it. Have a good Friday and a good weekend. I'm hopefully going to see you guys next week. Later.